That is not too big to ask, but tomorrow, that is what we will be doing. Clemensbaum, what do you think of RAII for resource handling? So RAII, for people who don't know, I actually used to do a lot of C++ programming, which is the only reason I know what RAII is. Normally, if you ask me a C++, one of these fancy C++ isms, I would tell you, like, I don't know what that is and I don't care what that is, but I do know what RAII is. That's resource acquisition is initialization. It's usually what that means. What that basically means is designing code such that a single logical unit, usually in C++ they're referring to a class, which is a glorified struct, basically. As soon as it has acquired any resource, memory, a file handle, a network socket, something that is a resource that has to be acquired and then released. RAII basically means that the class is considered initialized once that resource has been acquired, and it's not supposed to do anything additional until basically unless you make like a new class that does the next step. Without trying to go in and give a full example of what that is for everyone, and showing perhaps why it is kind of silly, I will simply say that the way that you want to design code in general is to understand the ways in which that code can fail in practice and design the code so that it properly handles those failure cases. What people often advocate in C++ is trying to write your code such that it handles, and I'm using that in quotes, all possible failures at all possible points. What that means is, if for some reason my code couldn't open the file handle that it was trying to open, I want it to automatically, through a series of exceptions and destructors and all these other sorts of things, unwind all the stuff that it had been doing up to that point in a way that makes it so that it is somehow conceptually cleaner. I never find code written in that way to ever actually work in practice very well. I find that it's actually very brittle to failure. And the reason that I find that it's very brittle to failure is because the things that people have done is they have translated, they have moved the job of thinking about the ways the code can actually fail into just a reflexive way of just sticking things in constructors and destructors and assuming that the unwinding of the stack will just do the right thing. But the answer is that usually when things fail in your program that you expect to fail, like a network socket can't be opened, or a network socket doesn't send the thing it needs to send, or a file can't be opened, usually what you really need is custom logic that recovers from that failure in a smart way, and that logic is often different depending on the circumstance. One file not being able to open is different from another file not being open. If I'm trying to open file A, maybe the thing that I want to do when it can't open is wait a few seconds and try again. But if file B can't be opened, then maybe what I wanted to do is just exit the damn program because nothing's going to be able to happen. And those are simple examples, but really, it's not that much more complicated than that when you really start programming a real program. Really, it's just about you need to think about the failures and you need to write code that handles the failures. So what I find a lot of C++ programmers who are gung-ho about RAII do that I don't approve of and would not recommend is they spend a ton of time typing in code that handles failures that will never happen. And then when their code actually does fail in the places where I would know that that's legitimately going to happen on a running system, it totally blows up. And yeah, they freed the memory and closed the file handles, but who cares? Like, you need the code to actually work. It doesn't matter if it cleans up after itself. It needs to actually work. And so if you can't even get the code to work, why are you bothering dealing with whether you close the file handle? That is not relevant. That is not part of actually the problem definition. That is a way of making sure that your code does not leave detritus around and leak handles, but it is not actually the primary problem statement of what's supposed to happen. So like most C++ design patterns, I find RAII to be a way that people excuse themselves from doing the hard work by doing busy work, which actually does not solve the problem that they needed to solve. Hope that answers that question.